Okay, so let's look at this one here. We have limit as x goes to 0 of secant x minus 1 over x squared. Of course, as x goes to 0, secant will, well, cosine is 1. Reciprocal of cosine is also 1. So secant of 0 would be 1. 1 minus 1 would be 0. In the bottom, we also have 0, so this checks out. We're dealing with a 0 over 0 limit. So we apply L'Hopital's rule. Take the limit as x goes to 0 of the derivative at the top, which would be secant x tangent x, over the derivative of the bottom, which would now be 2x. Okay, well, this checks out as another 0 over 0 limit, because secant will be 1, but tangent of 0 is 0. So this is 0, and of course, as x goes to 0, 2x is 0. So we did L'Hopital's rule, we got a 0 over 0 limit again. Well, that's okay. Take the derivative another time, and let's see what happens. Sometimes you do need to use repeated applications of L'Hopital's rule. So we do the derivative of secant times tangent. That'll be secant times the derivative of tangent. Derivative of tangent is secant squared, so secant times secant squared will be secant cubed, plus the tangent times the derivative of the secant. Derivative of the secant, remember, is secant tangent. So we're going to have tangent times secant tangent, or alternatively, secant x tangent squared x. And that'll all be over the derivative of 2x, which is 2. Now we no longer have a 0 over 0 limit, so we compute what we have. So we allow x to become 1. Secant of 1 is 1. 1 cubed is 1. Secant is 1. Tangent is 0. So that's going to be plus 0. All that over 2. So it turns out our limit is 1/2. Okay, our limit here is 1/2. Okay, so we're able to allow that to work out by actually doing a double application of L'Hopital's rule. Let's do one more here. Limit as x approaches 1 of the ln of x over x squared minus 1. We really would be very hopeless on this kind of a problem without L'Hopital's rule, I think. Because how would you get a zero factor to cancel out? Our other methods really would leave us completely lost. Fortunately, we have L'Hopital's rule, so we can apply it, because this is a 0 over 0 limit again. Right? ln of 1 is 0. 1 squared minus 1 is 0. So we are dealing with a 0 over 0 limit. So we evaluate by taking the derivative. Limit as x goes to 1 of the derivative of ln of x, which is 1 over x, over the derivative of x squared, which is 2x. This is no longer a 0 over 0 limit. So I just allow x to be equal to 1. Evaluate the top, it'll be 1. Evaluate the bottom. Turns out this one's also 1/2. This one is also 1/2.